A very good morning, and you're welcome to this week's Signpost webinar. We hope you're keeping safe and well wherever you're joining us from this week. Today, we are celebrating another important milestone at the Signpost series. Believe it or not, it's actually 5 years this week since the very first episode of the series went to air, and we are delighted that the series has gone from strength to strength since that 5 years ago. I want to pay special tribute to the dedicated team that makes it all happen. In particular, I want to say thank you to Yvonne Maher, who's in the background here today, who does a lot of the work in the background. Cathal Somers, thank you for your work in the program and joining us as co-host in recent months. Tom O'Dwyer, Noel Meehan, Mary O'Loughlin, Siobhan Kavanagh, Ivan Kelly, and Catherine Keane are all part of the team in the background. And of course, we want to say thank you to the founding members who are no longer in Teagasc, in particular Pat Murphy and Andy Boland. And of course, we want to say thank you to all of our contributors over the years. But most of all, we want to say a heartfelt thank you to you, the audience, for your interest and your engagement over the years. We really do appreciate it, and we hope that we'll have many more years ahead of us with the series. So getting back to today's topic, as we know, concerns about water quality and environmental sustainability are growing, and finding practical solutions for reducing nitrate leachings in agricultural systems is more important than ever. And today we're going to explore how plantains, a versatile and resilient forage species, can play a key role in mitigating nitrogen losses while maintaining pasture productivity. So we're delighted to be joined by Dr. Aoife Egan, who is catchment scientist on the water EIP with LawPro, and Dr. Patrick Forrestal, who is a research officer with Teagasc based in Johnstown Castle. Good morning, Patrick and Aoife. How are you today?
Morning.
Morning, Mark. Doing well.
Great to have you back again, Patrick. I know you've been with us before. And good morning, Cathal.
Hey
It's
Mark, how are you keeping?
hard to believe we're 5 years on.
5 years going strong and lots of great resources out there and hopefully many more years to come. So it's excellent.
I was looking at some of the earlier episodes there, and it was a little bit makeshift because we were in the heart of the pandemic at the time. I was set up in my daughter's bedroom at the time, and I had a few less grey hairs. But sure, look, the series has grown, so we're just delighted with how things have progressed since. So, Aoife, for those people that are joining us this morning that may have not come across LawPro, could you give us a little introduction as to what LawPro does?
Yeah, so LawPro is the local authority water program. So it works on behalf of the local authorities to protect and restore water quality in our rivers and lakes as well.
Excellent, excellent. And I know that Teagasc has a very strong relationship with LawPro, and we have there's a lot of collaboration going on there in terms of addressing water quality. And the asset program, of course, is probably the main program or vehicle for that. And Patrick, you're based in Johnstown Castle. You've been researching this area, and I know you presented at the dairy conference there last year as well in Limerick, wasn't it? Limerick Race Course.
Yes.
This is an area that you've been involved. Soil and soil nutrition has been an area that you've been focused on for a long time.
Yeah, and I suppose in particular the challenge of getting nutrients into plants to support growth and productivity while addressing the challenges that are there around lost pathways for those nutrients, including into water, as greenhouse gas emissions and as ammonia emissions. And I suppose trying to come up with practical solutions that farmers can implement on their farms to improve their businesses, also in terms of mitigating potential losses that might come associated with the production that's so important.
Great, great. And I know we did have John Finn with us. It's probably over a year ago now, talking about the good work that's been done there in Johnstown Castle in relation to multi-species sward. So if anybody wants to take a look back at that, you can find that on our YouTube channel. Cathal will be taking questions afterwards.
Yeah, Mark, look, this is really important. With my water quality hat on, this is a really important conversation today. And just to remind people, the Q&A function is there, and just get the questions in because it's a great opportunity. This is some new technologies come down the line, and get the questions in when you have the experts here.
Absolutely. And remind everybody that today's session is recorded and will be available on the Teagasc YouTube channel and podcast platforms. And the presentation will also be available on the Teagasc website. So Patrick will ask, and Aoife will ask you to share your screen with us. And I know you're doing a double act today, so we're really looking forward to that. So we'll hand straight over to you and look forward to questions afterwards.
Very good. Thank you, Mark. Can you see my screen coming
that looks
up?
perfect there.
You can? Perfect. And I'll just turn this pointer into a laser so we can move it around as we go along. So look, it's a pleasure to be here this morning with Aoife and to be speaking on this topic. And I suppose specifically we're going to talk about some work that we did that's been published looking at the potential of the addition of ribwort plantain to a grass clover sward to reduce nitrate leaching in pasture systems. And we did this work across 5 soils in a lysimeter facility over 2 years. So a little bit of background. Of course, many of you will be very familiar with white clover, but perhaps some less so, and ribwort plantain maybe less so again. So just a little bit of background. These are species that can complement the grass sward. So white clover, it's a legume, so it fixes atmospheric nitrogen, and it can do this through this symbiotic relationship that it forms in its root nodules with rhizobium bacteria. So it's breaking that triple bonded nitrogen, one of the strongest bonds in nature, and making it plant available. So think about this. The fertilizer that you buy, this process happens at high temperature and high pressure, often typically using fossil fuels. The white clover plant and other legumes are able to do this at ambient temperature and pressure. So this is quite powerful. And work by Teagasc has indicated that it has potential to fix anything from 50 to 200 kilograms per hectare per year of nitrogen. And you can think about this as essentially the local bioeconomy in action, where we're using a biological process to fix nitrogen locally right here in Ireland. And I suppose over time, farmers have been engaging with the use of white clover to a greater extent and becoming better at managing it. So what about ribwort plantain? Okay, so what we did in this study is we looked at what if we added one more species to a grass white clover mix. So ribwort plantain, and in the Gaelic language, or Os Gaeilge, something I've come to appreciate more over time is that the Gaelic words for plants or places, they often tell you something about the characteristics of that plant or that place. So Os Gaeilge slánlas, or health plant, or lus na slánta, so essentially, or the plant of health. Okay, so for many centuries, this plant has been recognized to give particular health benefits. So what about its role in a grass sward? Well, it's a non-leguminous plant, okay, so it's not fixing nitrogen, but it does have potential to root down to a depth of 1 meter, so it has a different root architecture than your grass or your clover. And I think that this can be important in terms of this challenge of, I suppose, chasing and retaining nitrate that might otherwise be inclined to be lost. It has been there's been work done and published showing it has a diuretic effect on cows. So it's reducing the N content of the urine patches because the cows are urinating to a greater, more frequently. Thus the urine nitrogen content is diluted and it's spreading over a larger area, which gives potential for plants to recover it. Also, colleagues have found evidence of improved drought resilience where it was part of multi-species swards, and indeed animal performance benefits. These multi-species swards, typically containing 6 or more species, in this particular study, we simply add it's 3 species, and we'll talk a little bit more on that as we go on. Also, this plant is reported to have biological nitrification inhibition characteristics. So this is slowing down the process by which ammonium converts over to nitrate. And if you can hold that nitrogen in the ammonium form for longer, it's less vulnerable to leaching as nitrate. And I suppose I was quite interested in this area because I also do quite a lot of work with conventional mineral fertilizers and also looking at synthetic nitrification inhibitors to include with those mineral fertilizers. But here's a plant that's producing this biological nitrification inhibition effect. So a little bit further background, some potential modes of action for reducing nitrate leaching loss in pastures. And as I mentioned, the current study focused simply on the addition of 1 additional species to a grass clover sward, so taking it to 3 species. Some really good work in this space has been going on in New Zealand, and this graphic from Dairy NZ shows the nitrogen cycling processes in pastures, and also summarizes some of the potential mechanisms for reducing nitrate leaching through plantain inclusion in these swards. And these include that dilution of the nitrogen load that I mentioned, also the partitioning of the nitrogen more to the dung or the organic form and potentially the milk versus having it in the urine. And Mike Deneen in Teagasc is doing some good work looking at that partitioning. Also the exudates of these biological nitrification inhibition compounds to slow down nitrification. The urine itself can also contain some of these type of compounds that could slow down nitrification in the urine, and also the potential for reduced drainage linking to increased evapotranspiration. So the current study, we really focused on the plant effects. Okay, so these would be the nitrogen retention due to the biological nitrification inhibition, also the potential for reduced drainage. But I think there's a few other points that we'll talk to that are important as well. And this is also the potential for increased yield and also potential of regulation of the end fixation by the clover or increased end scavenging by the sward that includes plantain. And I suppose following along on that theme of work done in New Zealand, this plantain potency and practice program led by Dairy NZ has measured average reductions in nitrate leaching of 26% over 4 years at Massey University and of 23% over 2 years at Lincoln University. And indeed, according to this article here by Dairy NZ, plantain is now recognised as an end leaching mitigation option by regional councils in these particular areas. So I suppose back in 2020, I was following these developments in the plantain space and the nitrification inhibition space generally, and we could see that there was an opportunity there to do some work under Irish conditions to complement other work that was going on here in Ireland, looking at drought resilience, reducing reliance on imported mineral fertilizer nitrogen, and animal performance benefits that were being seen in multi-species swards. And of course, as we mentioned at the outset, we're always in Teagasc looking for solutions that can help us to meet the challenges that we know that are there, including the need to improve water quality, and this includes reducing nitrate leaching. From the EPA in March 2025, this early insights indicator shows some good news in that nitrogen levels in rivers have reduced in 2024, but EPA also state that ongoing and sustained actions will be needed to reduce nutrient levels so that the ecological health of our waters can improve. So this means that for the farming community, we need to continue to, do everything, continue the good work and do things as best as possible, and also look for new solutions that can help us to improve as time goes on. So could plantain inclusion in grass clover swards play a role in meeting that challenge. So we'll talk a little bit about the results of the study that we conducted, where we examined the effects of that plantain inclusion in a grass clover sward. And we did this in 5 Irish soils. At Johnstown Castle, we have this facility, this lysimeter facility, with 5 soils, which range from well-drained to poorly drained, with the first 3 being relatively well-drained, all arranged here in this lysimeter facility. So we can do some very controlled experiments where they're all treated the same in terms of weather, and collect the data from them. So 3 swards were established in May 2021. These included a grass clover sward, if you like, as your standard control for a grass clover situation, a grass white clover with 30% plantain, and these were tonic line plantains, and also a grass clover 50% plantain, and these were seeded according to this target proportion recommendations of Grange et al. 2020. So those were the targets of plantain, recognizing that the proportion of plantain and other components in the mix will ebb and flow as the season progresses. So the lysimeters are of 1 meter depth, and leachate is collected in these drums here in this trench, and the leachate was analysed for a suite of nutrients, including nitrate. And today we'll focus mainly on the nitrate results. So some examples of the swards that were established. Here's a grass clover sward, and you can see here the plantain inclusion at the target of 30% and at 50%. And we use these 2 rates to see if there would be an additional benefit or advantage or disadvantages associated with going to higher populations of plantain. The nutrient application schedule over the 2 years of this study. So to begin with, in September of 2021, so in the autumn, we applied one single application of 30 kilograms per hectare of NBPT urea, and also a urine patch to simulate a urine patch applied in the autumn. The urine that was applied to these lysimeters was real urine from the Johnstown Castle dairy herd, which is grazing a mixture of pastures. So all plant treatments receive the same urine. So there's no, I suppose, urine effect at play here. We're simply looking at the plant effects in situ. We then came on in the spring and simulated as another urine patch, so a spring urine patch. And in the summer, there was an application of cattle slurry applied to simulate a trailing shoe application. There was no further nutrient applications, but in the spring of 2023, we applied cattle slurry again, if you like, simulating what a farmer might do with that, first round of slurry going out, and a further urine patch in May of 2023. So at this point, I'll turn it over to Aoife, who will take you through some of the results that we saw. And Aoife will turn on her camera there, yeah.
Yeah. So can you see this screen?
Yes, but just put it in the presentation mode.
Yeah, sure, no problem. Now, so I am going to take you through the results of this plant trial. So firstly, we'll look at the effect of sward type on nitrate concentration in the drainage water. So the first soil type we'll look at is Oak Park soil. So this is the free draining sandy loam soil. Just to point out that, So just to point out that the lines that you'll see with the white circle represent grass clover, the black squares represent grass clover and 30% plantain, and the grey triangles represent grass clover and 50% plantain. I've also included the red dotted line, which is the MAC nitrate level, which is the maximum allowable concentration of nitrate. in drinking water, and this is a standard set down by World Health Organization. So I just use this as a standard to kind of compare results to. But there's other standards available that are lower than this for river quality as well, or river water quality. So the results will be sorry, also, I have included where the urine and slurry patches were added here, just on the x-axis. That Patrick has just explained. So first of all, we'll look at our grass clover results. So the general trend with these results show that there was a leaching period in the autumn winter period here in both years, in 2021 and in 2022. But when we look at this compared to our plantain, our 30% plantain, and also our 50% plantain, we can see that this leaching is much reduced compared to grass clover. And then we compare it to our MAC standard, nitrate standard. We can see that there was really only one leaching occurrence here in the plantain treatments that breached this MAC level as well. So we can see that the inclusion of plantain really has reduced the concentration of nitrate in the drainage water. So then looking at our Elton soil, which was a well-drained fine loam soil type. Similarly, again, we see leaching occurring in the autumn-winter periods. So I also to point out that a urine patch was actually added here mid-September. So we will see that the leaching is just slightly higher in 2021-22 compared to no urine added here in the same period between 22 and 23. So we can see compared to the plantain treatments that grass clover leaching is much higher. And then also when we compare this to our MAC level, we can see that there were that the plantain, leaching from the plantain did not breach the MAC level for the Elton soil. And then looking at Clonroach is also a well-drained fine loam soil type. Again, similarly, leaching occurring in the autumn-winter periods. But comparing this then to our plantain treatments, we can see that it is reduced, particularly reduced for the grass clover plantain 50 treatment in this case, which was where we see that there was no breaching of the MAC level. But again, although plantain 30 breached the MAC level in this instance, it was just on 2 occasions compared to grass clover during the duration of the plant trial. And then moving on to the poorly drained soil type. So Cathal Somers is poorly drained and it's a clay loam type soil. Again, we see leaching occurring in the autumn winter periods. But just to point out this high leaching that occurred here just after the second urine application. So this occurred because of the nature of these soils, they're high have a high clay content, and it was a particularly warm, dry spring in 2022, and it was visibly evident in the lysimeters that the soil had begun to crack. So we can attribute this to preferential flow in the lysimeter occurring here, which was also observed with the plantain treatments as well. So we can see here that in this case, all 3 treatments were below, the leaching was below the MAC and nitrate level. And then looking at the Rathangan soil, which is also a poorly drained sandy clay loam soil type. Again, we see the same similar leaching occurring in the autumn winter periods, and also this preferential flow peak here, which was observed with the plantain treatments. And we can see the plantain, the leaching in the plantain treatments was below the MAC level for this soil type too. So then we looked at the annual nitrate leaching. So in the first year here we can see the black bar represents grass clover, dark grey represents grass clover with a 30% plantain, and light grey represents grass clover with a 50% plantain. And we can see here that The general trend is that there was reduced nitrate leaching in the plantain treatments compared to grass clover. In particular, there was a statistically significantly less leaching in the Elton and Clonroach soil in the first year of the trial. And then looking at the second year of the trial, again, we can see there was a statistically significantly lower nitrate leaching in the plantain treatments compared to the grass clover. So this could be due to the plantain just becoming more established in the second year of the trial, but also biological nitrification inhibition could also be taking place here too. And then looking at the drainage volume, so this is the amount of water that actually went through the lysimeter system. This is measured in millimeters. And again, the general trend is that there was less water that went through the system in the plantain treatments compared to the grass clover. We can see the Oak Park soil, there was statistically significantly less in the plantain 50 compared to the grass clover here. And in the second year, we can see that, again, same trend, that there was less drainage volume in the plantain treatments compared to grass clover as well. And overall, just to point out that there was 1 to 16% overall drainage reduction in this trial, in the treatments, in the plantain treatments. So then looking at the yield data, so this data is work that we're currently looking at. It is yet to be statistically interrogated. We plan to get this written up and to publish this work soon. So we'll just take you through kind of what our observations are on this so far. So we can see that in the first year, the general trend tends to be that there is a greater yield in the plantain treated grass compared to compared to the grass clover in the first year of the trial. However, in the second year, we're seeing an increase in plant yield just in the free draining soils compared to grass clover, so in Oak Park, Elton and Clonroach. So now I'm going to pass you back to Patrick, who will take us through, just discuss the results in terms of plantain's role in reducing nitrate leaching.
Thank you, Aoife. And I suppose just to pick up on some of the potential mechanisms for the reductions that we observed in this study, I suppose that's an area that we're always curious of. And in this particular study, we didn't have some of the mechanisms at play, such as the dilution of the urine, the partitioning of the nitrogen load within the cow. So I suppose these are further effects or further mechanisms that would be at play out of the pasture with the cow. But as Aoife mentioned, the plantain inclusion did reduce the drainage water volume, anything from 1 to 16%, and we attribute this to increased evapotranspiration. And you can also see some extra yield there, which is going to take water to produce. And that would tie in with work that's been done in New Zealand that also indicates a trend towards reduced drainage volume with the inclusion of plantain. Okay, and I suppose the biological nitrification inhibition by the plantain, this is an effect that that is at play in this particular study. It does appear that the plantain is able to hold on to the nitrogen in the soil for longer, using this nitrification inhibition. But I think there's also a role for the deeper rooting of the plantain. So with the nitrification inhibition, keeping the nitrogen out of that nitrate form where it's more vulnerable to leach down through the profile for longer helps. But also that scavenging potential of the plantain means that it has the potential to chase nitrate deeper into the profile for longer. So that could well be a potential mechanism at play here. Additionally, as Aoife mentioned, we think that the biological nitrification inhibition of the plantain may have been increasing over time as the plantain became more established, because we saw stronger reductions in the second year compared to the first year. Also, the yield data set that we're now really getting into and is complete does indicate this increased yield with the 30% plantain over the 2 years, particularly on the more freely drained soils. So this is a potential mechanism for reducing nitrate leaching. But I suppose as we get into that data, we also see this delivery of greater early growth by the plantain. And we think that this is quite important during critical time periods for leaching. So for example, following a spring urine application, the plantain treatments were putting on more biomass early in the spring, which is a potential advantage for farmers seeking to have early forage for the dairy cows. But also that means greater potential for scavenging of nitrogen from those urine patches while the leaching pathway is still open. Also, the nitrogen offtake data is giving us some insight also, and we do suspect that the proportion of N offtake for the plantain treatments that came from fertilizer, dung, urine, and slurry nitrogen recovery may be higher compared to the grass clover treatment, which we suspect may have had higher nitrogen fixation or just was not as actively growing during the times where nitrogen scavenging was important, particularly in the early spring. And Aoife, we'll just go on to the next piece there. Yeah, so we did observe in the lysimeters, although we didn't have the resources to do plant separations, which I think would have been valuable. We did observe that plantain regulated the clover content of the sward in this high urine load setting. So visually, we could see that the plantain was, I suppose, regulating the balance of the species in the lysimeters. I suppose importantly also, we did see that the majority of the benefits in terms of reducing nitrate leaching could be achieved with this target population of 30% plantain rather than the higher population of plantain. And I think this is useful in the sense that I think that this is a good kind of agronomic compromise based on the yield performance that we saw and how the swards looked over the course of the season. Okay, very good. And I think with that, I'll turn it back to Aoife to summarize. Yeah.
So just in summary then, I suppose in terms of nitrate leaching, the inclusion of the tonic line ribworth plantain in grass clover swards reduced the drinking water nitrate maximum allowable concentration exceedances from 28 in grass clover to 7 with 30% plantain inclusion and 4 with 50% plantain inclusion. And also reduce the mass of overall annual nitrate and total N loss from these soils. So in terms of yield, the trend was for increased yield for plantain treatments in the first year, and the trend in the second year was for increased yield in the free draining soils, particularly in the 30% plantain treatment. So in conclusion to this, I suppose including plantain reduced leaching from a grass clover sward and increased our dry matter yield. And it also shows some promise as a biological solution to reduce nitrate leaching. So this work has also been published. So if you'd like to read this publication, you can click on the link to get a copy of that. So I suppose in terms of farming for water, is there a support for plantain establishment through the Farming for Water project? And so the answer is yes, there is. So through Measure 5 in the Farming for Water EIP, which is for the multi-species swards measure, this includes so in terms of the multi-species, it includes the inclusion of 30% plantain. This is a source control measure. There's a payment rate of €300 per hectare with a minimum of half a hectare and a maximum area of 10 hectares at 30 kilograms per hectare. And so there's more information available on this on your measures information booklet and the Farming for Water, particularly on page 16 is the information on the multi-species swards. And you can also visit the website for more information or speak to your ASP advisor as well. So Patrick might just summarize here the future direction of this type of work.
Aoife, yeah, and I suppose, look, just to recognise that there's a lot of good work going on in this space by colleagues in Teagasc and around the country, in other organisations, and also in New Zealand. But I suppose a few areas that kind of come up from this work include the role of varietal selection for biological nitrification inhibition and the temporal growth pattern optimization. I mentioned that we used tonic line plantain variety in this particular study. So tonic is one variety of plantain, and there's been breeding from that tonic cultivar. So it may be the case that other plantains are out there, but what's the role of different varieties in terms of their ability to provide this biological nitrification inhibition effect. Also, I think N tracing to distinguish the different sources of the N that ends up in the plant in a grass, clover, plantain sward could be useful, and I think some of that work is going on. Also, I think from this study, look, it was in this lysimeter facility, so it's we don't have cows grazing over the top. I do think it would be useful to measure leaching losses in Irish conditions under the full grazing condition, the farmland condition, where you have the cows grazing over the top. And I also want to acknowledge John Murphy, who did a lot of the management of the harvest, etc., in the lysimeters, and John's good work in doing that. Also, the lab staff at Johnstone Castle for analysis, and DLF Seeds provided the seed for this particular experiment. So with that, thank you very much for joining today, and we'd be happy to take any questions or thoughts that you might have to share.
Thank you, Patrick, and thank you, Aoife. Really enjoyed your presentation, and lots of questions coming through. Just maybe a few questions on the methodologies that you used, but just I suppose from a farmer's perspective and a practical perspective, what do you see as being the kind of key recommendations coming from this work?
Yes, it's a good question. Look, I suppose this work was done under the conditions that are laid out there. It shows a lot of promise, I think, this technology. So there was quite a lot of work done in New Zealand and ongoing in New Zealand, and you can see that actually it's recognized by a number of the councils there as a nitrogen loss mitigation tool in New Zealand. So I suppose we were curious as to see, how would that stand up in some of our soils. You can see that the uptake of plantain is supported in the water EIP, and also as part of multi-species swards in the multi-species sward measure. And certainly this work does support that use of plantain in our pasture systems as a tool to reduce nitrate leaching. And I suppose working our way into getting that rolled out and getting the agronomy aspects of it correct will be important. But I think that's a journey that we've already started to go on. So I can see it being a useful tool, and this work and this published paper that Aoife has recently published certainly supports its use as a tool to reduce nitrate leaching.
And Aoife, Patrick mentioned there the supports that are available for that. Could you maybe just talk to us about that's available for incorporation of plantain?
Yeah, so just I mentioned there on my slide that in terms of the EIP project, that there's a payment rate of €300 per hectare of multi-species swards. There's you to sow a minimum of 0.5 a hectare and a maximum of 10 hectares, 30 kilograms per hectare. If you want more information on this, you can look up the Farming for Water website. This is measure 5 is a measure for multi-species swards. But also, if you speak to your ASP advisor about this, they'll be really good at advising you on this inclusion of
The
multi-species
fact that it's
swords.
being funded, I suppose, suggests that it's a viable option for mitigating nitrogen loss, and that that it has proven itself. And I suppose I know the drought resilience is as well as a really important part of the plantain. One of the characteristics, it has that deeper root. I think that has been mentioned before in the series. If we are trying to build resilience for future drought events, that plantain is an important tool for that. Patrick, is that something that you have found also?
Yeah, I think that that's one of the mechanisms by which it's just improving the scavenging potential of the sward. So where you have that a deep rooted component in the sward, it has a potential to chase or bring back up nitrate that may be moving down through the profile. And I think that that's probably particularly important in setting of urine patches where you have a large N load relative to the plant's ability to take it up and produce from it. So the longer you can sustain growth from that urine patch, which has naturally the nitrogen tends to be moving downwards, the greater period to recover it. And I suppose kind of on the practicality side of things for farmers, we did see that that early spring growth, and I think that the varietal aspect of early spring growth in plantains is an area that could be explored further. Can it help to fill a gap there for farmers early on? We did see good persistence of the plantain in the 30% treatment over the 2 years of this study. And I suppose other work by colleagues at Teagasc and others has been showing animal performance benefits, particularly for finishing of animals. So I suppose there's a kind of a multitude, if you like, of potential benefits, and then it's down to how do you get a good establishment and maintain it in the sward. But plantain does seem to be able to stick in there quite well.
Okay,
and we're seeing
there
that
are a number of questions coming in around the persistence of plantain there, and are there particular conditions that are required to support that?
Yeah, well, I suppose our agronomic data that Aoife presented gives us maybe some clues there in that in this 2 year study, at least, in the first year, the plantain treatments tended to deliver a greater level of yield. We saw that trend towards higher yield with the plantain treatments. But in the second year, it was the free draining soils that had that trend towards higher yield, whereas the heavier, those clay, heavier, less well drained soils, the trend seemed to be the other way. And so perhaps also owing to its potential to help in a drought situation, those free draining soils may be a place where they persist to a greater extent than in a wetter, heavier soil. But I suppose that's an area that could be explored and evaluated to a greater extent. But that's if you like the hint that we can see from this particular study.
Great. Cathal, lots of questions coming in here. Really good questions coming in from our audience.
Yeah, a load of questions coming in. So we'll fire through a few of them anyway. Some technical ones start out. How did you collect the cattle urine, Aoife?
The cattle urine?
Yeah, the cow urine for the experiment. How did you collect it?
I think maybe Patrick might take this one because
yeah. So this was collected when the dairy cows came in from milking. Nothing too high tech, just using a bucket to go around and collect it as the cows urinate. So when they stop walking and when they walk in and they stop walking, they're inclined to urinate as they're getting ready for milking. So basically collected with a bucket, we collected the adequate amount, and it was mixed and homogenized and refrigerated and then applied. So it's the real stuff that was used. Yeah.
So only the real stuff. And the lysimeters, how deep are the lysimeters?
They're a meter deep.
And is that natural soils, or is it filled, or do you take them out naturally?
Yeah. So these are intact cores. Yeah.
Oh, perfect. And there's kind of questions around the practical element of seeding rate. What kind of seeding, if there's a farmer listening now, off the top of your head, maybe you don't know, but what kind of seeding rate should they put in? And on top of that, can they sow it directly into a grass sward if they wanted to?
Okay, so just on the seeding rate, so I have it across from me here. So the paper, I should mention, is open access and available, and in table 2, the seeding rates are there. So it was perennial ryegrass. These are rates kilograms per hectare, 16.2 kilograms per hectare perennial ryegrass, 3.6 kilograms per hectare of white clover, and 4.3 kilograms per hectare of ribwort plantain. And we also have in table 2 the seeds per hectare that that equated to, because remember, yeah, different varieties might have different seed weights, so those details are there in the paper.
Yeah, and you're looking for 30% plantain, isn't it?
Yeah, exactly, and we're targeting this 30% plantain in the sward, recognizing that that will ebb and flow over the course of the season. Can it be put into an existing grass sward? I did read some articles from New Zealand where they were basically spreading some plantain seed onto existing pastures, either in slurry or with the fertilizer over time. And I suppose that's maybe a bit hit and miss, but they were seeing over time that they were seeing some plantain appear into the sward. But that in that particular setting, it was also combined with a reduction in the chemical nitrogen rate, which probably let those seedlings get established. So I think putting it into an existing sward is probably going to be very specific to the timing of how you put it on and how much competition the seedlings have, and what the weather conditions are.
Yeah.
We've a few questions just on animal performance, Patrick, and maybe it's not fair to ask you those questions because we're looking at more of the environmental aspects of it. Do you have any comments to make on that? Just in terms of animal or yields, or was there anything observed around that?
Yeah, I suppose in this study we're not looking at animal performance, but some colleagues at Grange, for example, have done some really good work looking at multi-species swards that would also contain plantain, and how these might improve animal performance and finishing and carcass weight. So there is a body of evidence building there, and Ellen Fitzpatrick, who's based at Johnstown Castle, is managing the dairy beef herd there, including the milk, including the multi-species sward. So I suppose our knowledge of the benefits for the animal performance is growing, and they do seem to be there. Yes, but this is not my primary expertise, so I would defer to colleagues who know more about this topic. Yeah.
Just looking at some of the results there, in the heavy Castle Comer and Rathangan soils, there was we could see there was a bit of an end load leaching, and I suppose a lot of the science that we talk about is light soils more leaching, heavier soils less leaching. Just can you comment on that?
Yeah, absolutely. So look at like Aoife showed that after that spring event in the first year cycle, after the spring urine application, we had this high nitrate concentration coming through, which we attribute to a level of cracking or facilitating some preferential flow in the lysimeters in these clay soils. So these two heavier soils were clay soils, or higher clay content soils. And we do typically think of these soils as being poorly drained, right? So they don't dry out as quickly, for sure. But if these soils crack, they can open up and provide a pathway down. So these lysimeters are only a meter deep. But oftentimes these poorly drained soils, as we might think of them, if they're farmed at high intensity, they may have drainage systems underneath them. So once the nitrate moves downwards in the profile, it may have a conduit out if the soil is drained. So that's something just to bear in mind. And I think that event that we saw in the spring after the urine application is a large part of the reason why we saw high levels of nitrate loss in those two more poorly drained soils in that first year, relative to the freer draining soils, which weren't subject to that cracking or occurring.
And I suppose practically for farmers, should they be looking at kind of targeting plantain to specific fields or parts of their farm that might be more susceptible? And if so, how would you identify those susceptible kind of areas to nitrate leaching?
Yeah, well, I suppose this is probably linking into the resources of the of LawPro and of the advisory service. Linking with your advisor and walking the farm, getting a sense of where those riskiest areas on the farm are, and there are resources there to help with that search, and often farmers themselves know which are the fields that are the most free draining ones, the most likely to be leaching loss. And I suppose if you also want to incorporate that drought resilience in aspect into your farm, farmers tend to know which are the fields that tend to burn up first when it gets dry. Often they're the free draining ones, the ones that will if it's wet, be vulnerable to leaching loss down through the profile. But then if it turns and gets dry, you go from wondering if it'll ever stop raining to having a few dry weeks and then kind of praying for rain to come. And those might be some good sites to target bringing some plantain into the farm. And I suppose we're coming into the time where farmers will be making those decisions about reseeding paddocks and whatnot. And I suppose just to put this on their radar as something to start to explore, because look at the changeover from ryegrass swards to grass clover swards, or to swards that are multi-species or include plantain. That's something that happens gradually on farms, typically as reseeding goes along. So it's there is an opportunity there, I suppose, if you're curious and to engage with it, to include this in your reseeding plan. And
Patrick, can it be incorporated successfully into existing swards? A few questions here coming in. Can plantain be purchased on its own, or is it something that it could be advised to be mixed in with some other species?
Yeah, well, I suppose it's typically available as part of mixtures that are there, and probably mixtures that are commercially there tend to align with the support schemes that are there. But I'm sure if you explore with your seed supplier, if you could get the seed on its own, that is likely to be possible. There are different commercial companies that have plantain varieties available. So typically it's not something that's on the forecourt, but I'm sure it could be explored. And then to the establishment of it in existing swards, it's back to what I mentioned earlier. Yeah, you could have a great take or you could have a poor take, and you'd have to be prepared, I suppose, where you're trying to put it into an existing sward to bear with it, recognizing that depending on the weather conditions and so on, you might get a great stand or you mightn't get a great take. And just to keep doing it seems to be the approach that I was reading people do, where they're trying to take that approach.
There's a lot of questions around, obviously, the productivity and will farmers get more milk from plantain, but there's a number of questions around the palatability. Will the animals eat it? 30% we're looking for. How palatable is it, or will animals eat it? I suppose there is work done on multi-species swards before, but
yeah, it does seem to be quite palatable, and animals are inclined to graze it and graze it out quite well. And that there is some work done, or there's a thought process that because of the deeper root system, that it has maybe other micronutrients, etc., that can be beneficial to animals, or have activity against worms, for instance. That can help the overall health of the animal and their performance. So a lot of questions on the animal performance side actually coming in naturally enough. That's an important part of this. And Teagasc is doing an increasing amount of work in that area. And indeed in Johnstown Castle, we have dairy herds that are grazing multi-species pastures, including plantain, and also the dairy beef system. And there's work going on in Grange as well, and at Moore Park. So there's more knowledge being generated in this space all the time.
There's a good few kind of questions coming in around that you kind of focus on urine and slurry and clover. Did you look at chemical nitrogen?
Yeah, it's a good question. So with the exception of that very first chemical nitrogen application in the September of the first year, when the sward was, I suppose, in maybe more of an establishment phase, we didn't apply any nitrogen fertilizer. That being said, with the urine patches and the slurry and the clover fixation, there was certainly no limitation in nitrogen availability in this in this particular setting. If anything, it was, if you like, a stress test for plantain in terms of could it have an impact in the highest loading scenarios where you have these urine patches occurring and even multiple urine patches occurring.
Yeah, and the botanical composition of the project, and I know we've talked about persistence already, but I suppose there's a question here around did it persist at 30%, and if it didn't, did you see a reduction in the ability to stop nitrate leaching?
Yes, it did persist. So we ran this for, well, the study for 2 years, but I suppose from the time of establishment, it was even a little bit longer than 2 years. Yeah, the 30%, it did persist, and it seemed to keep a good balance in the sward with the clover and the grass. The 50% seemed to, at times, because it was so vigorous at times of the year, I think it actually kind of shaded out some of the other components of the sward, and I think maybe the grass and the clover might have struggled a little bit with the 50% plantain there. And then when the plantain came to a time of the year where it had a little bit less performance, you could see some openness in the sward. But at the 30%, we achieved most of the nitrate reduction benefits and also very good agronomic performance.
And given that we're talking about nitrate leaching being reduced, so obviously deeper roots scavenging more nitrogen, holding more back. Can we cut back on our chemical or our slurry or something and still grow the same amount of herbage?
Yeah, well, I suppose certainly I think it can play a role here, and I think part of the mechanism for the reduced nitrate leaching was actually that we think that the swards, or we suspect that the swards that had plantain in there were actually scavenging more of that urine, fertilizer, and slurry nitrogen, and maybe holding back the fixation a little bit, or they were doing that at very vulnerable times of the year. And I suppose that end fixation in this particular study is almost a kind of proxy replacement for chemical nitrogen fertilization that might be used in many farms. So I think that there is potential there. How much to pull back by, that's another question. But I think it can play a role. Yes.
And there's a kind of, we went on the biodiversity trail there for the last month, so there's a kind of question around biodiversity where if we kind of are recommending using a certain type of plantain, will it affect the native plantains?
Yeah, that is a good question. I suppose since childhood, I've been looking at various plantains growing around yards and whatnot, and many of you might have noticed them as well, such as the broadleaf plantain that we see maybe growing in dry areas. I think in the pasture setting, particularly the intensive pasture system, where we're trying to reduce nitrate leaching from grass or grass clover swards, the addition of ribwort plantain is, actually bringing something extra to the biodiversity picture rather than necessarily taking away from it. And indeed, look, plantains have been around for a long time in our pasture systems. I was reading a book back a couple of years ago, and I came across reference that they can see in the pollen record, where they believe that the pasture systems became prominent in areas of Ireland just because of the plantain pollen showing up in that pollen record. So it's, I suppose, an important species that's been around for a long time in Ireland.
Okay, we're right up on time. Aoife and Patrick, thank you so much for joining us today and sharing that good work. If somebody wanted to read the actual paper, where would they be able to access that? Just a question coming in there.
Yeah, so yeah, if you Google Egan and Forrestal and plantain, it should pop right up. It's published It's published in the Journal of Agriculture, Ecosystems and the Environment, and is published open access, so you should be able to just download it yourself and read it. Yeah.
Brilliant. That's great. Okay, thanks again. Next week, we're going to be joined by Professor Pat Dillon, who is the Director of Research in Teagasc, and he'll be talking about putting the Better Farming for Water campaign into action. So I know Pat did an excellent paper at the last dairy conference, so I think a version of that will be presented. And just for your interest, the Teagasc, in conjunction with the Irish Farm Buildings Association, are hosting a series of meetings about farm buildings across the country this month. So if you want to find out more about those, go to the events section on Teagasc, and there's lots of really good speakers lined up for that series. So I encourage you, if you are working in that space, they could be very, very useful meetings to attend. Cathal, thanks for helping with questions today, and thanks to Yvonne in the background with supporting the technology, and of course organizing the speakers and the all of the technology, as I said, in the background. And we will see you again next Friday. And until then, thanks for watching.